Hi friends, we're back. It's Mrs. Testa. So we are going to continue in chapter 10 today, and now we're going to talk about some special things with zero and negative exponents. So please have your packet out if you printed anything out, or just have some paper and a pencil near you. Okay, so we're going to go over some really important rules today. So we've been talking about exponents in this whole chapter. In the last lesson, we learned about quotients and powers. So now we're going to talk about those special circumstances when we have a zero as an exponent or a negative as an exponent, because they both have very specific rules. So let's look at our rule for zero first. So for any non-zero number, when we have a power of zero, the number equals 1. So anything. Oh my gosh, my stylus is terrible today. Again, I don't know what's happening. Let's try that again. Anything raised to an exponent of 0 equals 1. 10 to the 0 power, 1. 100 to the 0 power, 1. A billion to the 0 power, 1. Anything raised to an exponent of 0 equals 1, except a 0 itself. You can't have 0 to the 0 power, because if you do, it's undefined. Okay? Anything else raised to the 0 power is 1. Doesn't matter how big or small the number is. Anything raised to the 0 power is 1. A big, tricky question on a lot of things is 0 to the 0 power, because that's the only thing that doesn't go by that rule. When you have this 0 to the 0 power, it is undefined. It's not 1. Anything else is 1. Okay? So that's a pretty easy rule to remember. The next rule we're going to talk about is when you have a negative exponent. All right? So for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. So if we have 4 to the negative 2, we're actually going to flip that over to put 4 to the positive 2 on the bottom. So moving a base with a negative exponent across that division bar changes the exponent to positive. Okay, so this negative 2, when we put it in the denominator, became a positive 2. This negative n became a positive n. All right. So basically, we don't want negative exponents. We don't like negative exponents. We are going to make the negative exponents into positives by flipping it over. Okay? Flipping it over 1. And here's the rule. You must use a 1 as a placeholder if you need one. Oops, I spelled placeholder wrong, guys. If you're in my class, you know Mrs. Tess is not the greatest speller. As a placeholder if needed. All right. So what we're going to do here, if we have 3 to the negative 4, we're going to move that down under that imaginary kind of fraction bar, okay? But we need a placeholder. So we need something in that numerator, so we're going to use a 1. When we move it down, that negative becomes a positive. This is a placeholder. I know it's weird. Okay, it's really weird, but you'll get used to it. Okay, we can even say 1, 3 times 3 times 3 times 3, so 3 to the 4th power is 81. My answer here is 1 over 81. So we don't want that negative exponent. We are going to flip it and use a placeholder 1. All right, we're going to flip it across that denominator. That division sign. All right. So let's look at the second one. We're going to use our rules for power of powers, right? So if we have the same base, which we do here, so I have a negative 8.5, we're going to keep that base. We're going to take these two and we're going to add them. So I have negative 4 plus a positive 4. Uh-oh. We all know that when we have opposite numbers, it gives us 0. Okay? Anything raised to the 0 power, doesn't matter what it is, the answer is 1. Whoops, the heck? Anything raised to the 0 power, the answer is 1. So my answer there is 1. All right, let's look at our quotient of powers property now. I have 2 to the 6 minus 8. We're still doing that the same way. Right? So now I have 2 to the negative 2. I do not want a negative 2. I don't want an exponent that's a negative. So literally, I'm going to flip it. So I'm going to say 1 over 2 squared. And I can finish that up as 1 over 4. So when I went from 2 to the negative 2, I used my placeholder 1 here. And this negative 2 became a positive 2. So now we don't have a negative exponent. Our goal here is not to have a negative as an exponent. Okay, so we just have to flip it around. So if you're comfortable, try to do 1, 2, and 3. Pause the video. If you need to look at the lesson again, this first part of the lesson, watch it again, then try. But try your hardest to do 1, 2, 3, and 4, 5, 6. And then come on back and we'll do them together. Do as much as you can, okay? Okay, friends, let's go over these. So this first example I have is 4 to the negative 2. We don't want that negative up there. So we know we have an imaginary over 1, right? So we're going to flip this down. So this is going to become 1 over 4 squared, positive. And that's the same thing as 1 over 16. My answer here is 1 over 16. All right. Okay. Now this one, we have a negative 2 to the negative 5th. Okay. We have an imaginary fraction line there, right? So because we don't want this guy up here, we don't want that negative exponent. So we have to flip it and put it under there and have a placeholder. So I have a placeholder 1 as the numerator. Everything that was on the top is going to move to the bottom, and the exponent is going to become a positive. Okay? If you put this in your calculator with the parentheses, remember, we would get 1 over negative 32. Remember, those parentheses are really important. Okay, we're going to use our power of powers property or multiplication, our rules for multiplication with the same base. So this one is going to be 6 times negative 8 plus 8 power. We know that that's a 6 to the 0. And our rule here, any number at all, it doesn't matter what it is, when it's to the 0 power, your answer is 1. Okay. All right, I'm going to use my rules here for the quotient of power. So I have the same base. So now I have a negative 3. I'm going to keep my parentheses on there, to the 5 minus 6. Okay. So now I have a negative 3 to the negative 1. I don't want that negative 1 there, right? And I have an imaginary line there, because we can make any whole number into a fraction just by putting it over 1. So I am going to move that, have a placeholder 1, and I have 1 to the negative 3 to the first power. Remember, we don't need to the first power, so we have a 1 over negative 3. The more you practice these, the better. Okay. Again, remember, there's lots of methods we could use for number 5. I am going to rewrite this so I can get rid of my multiplication. So I have 1 times 1 over 5 to the 7th times 5 to the negative 4th. So I'm going to say 1 times 1 is 1. I have the same base here, so it's 5 times 7 plus negative 4. So this is a 1/5. I'm sorry, 1, 5 to the 3rd power. There's no negatives here. My answer here is 1 over 125. Okay, for this first one, I need to rearrange this, so I'm going to do the top part of this first. So I have 4 to the 5 plus negative 3 over 4 squared. 5 plus a negative 3 is going to give me a 2. So I have 4 squared over 4 squared. That gives me a 4 to the 2 minus 2, which is 4 to the 0. Any number raised to a 0 power is 1. Okay, ladies and gentlemen. Let's move on here to example 2. All right, so we're going to have to simplify expressions now with these. So stick with me, friends. So let's look at this and let's just break it up here. This is really like saying -5 times x to the 0 power, right? Now we know that x to the 0 power is 1. Anything raised to the 0 power, even if it's a variable, is going to equal 1. So my answer here is -5. Didn't that look scary? And has a really easy, simple answer. Okay? I'm going to rewrite b because I can see that I have the same base there. So I'm going to rewrite this as this. 9 times y to the -3 over y to the 5th power. That's going to give me 9 times y to the -3 minus 5. That's going to give me 9 times y to the -8. So I don't want that -8. I can't have that exponent as -8. Remember, there's an imaginary fraction line there, right? So I'm going to take this whole thing and I'm going to flip it down there. So I'm going to leave my 9 on the top because we don't have to move that. And we're going to leave my y to the +8 here. So my answer here is 9 over y to the 8th because I have to flip this y to the -8 to the bottom. All right. If you are comfortable trying these out, try them out. Okay, pause the video. Okay. Let's look at number 7. 8 times x to the -2. Remember, we could break that up like this, right? And we have that imaginary fraction line. We don't want this up there. We have to move it down there, but the 8 can stay. So we're going to have 8 over x squared. And that's my answer. Your goal here is not to have any negative exponents. All right. B to the 0 times b to the -10th. Well, you should know right away, bells and whistles should be going off in your brain. What is b to the 0? It's 1. So I can rewrite this as 1 times b to the -10th. Well, 1 times b to the -10th is just b to the -10th, right? Imaginary fraction line, I don't want b to the -10th. I want a positive exponent. How do I do that? I have to take the whole thing and flip it underneath. So use my placeholder 1 and b to the 10th power. 1 over b to the 10th power is your answer there. All right. For this one, I'm going to rewrite this one. So I'm going to have z to the 6th power. If you're not used to my cursive z's, they're my favorite. Times 15 times z to the 9th power. Geez, that 9 is not cool. Sorry, friends. Erase that 9. I don't know what the heck happened there. Okay, z to the 9th power. Still not great, but that's okay. All right. I want to use my quotient of powers property here, right? So this is going to give me a z to the 6 minus 9 on the top. I'm going to leave my 15 on the bottom. So now I'm going to have z to the -3. My 15 is still on the bottom. I don't need to move that 15. There's nothing I can do with it, right? Okay, now I have z to the negative 3. I don't want this negative exponent there. I can't have it there. So I need this to flip that to the bottom. So I'm going to need a placeholder 1 up here. And I'm still going to have my 15 down here. But now it's going to be times z to the third power. And we don't need that time sign. We can just say 1 over 15 z to the third power. So the rule here is to get rid of those negative exponents by flipping it over that division line and using a placeholder 1 if we need it. All right? Take a deep breath. You're going to need some practice. Okay. Word problems, everybody's favorite. Okay. A drop of water leaks from a faucet every second. How many liters of water leak from the faucet in an hour? Okay. So, the first thing we need to do is convert hours to seconds, right? So to do that, remember when we did this earlier in the year, we had 1 hour when we want to cancel things out. So we know there's 60 minutes in 1 hour, and we can cross the hours out. And then we know that there are 60 seconds in 1 minute. And then we can cross the minutes out. So now we only have seconds left. So 60 times 60 is 3,600 seconds. So that means if a drop of water leaks every second, then there's going to be 3,600 drops. Okay. So we also know that a drop of water has 50 to the negative 2 liters in it. So I need to times that 3,600 times 50 to the negative 2. Now we know we don't want that negative exponent, so we're going to rewrite this as 3,600 times 1 over 50 to the second power. So 3,600 times 1 is 3,600 over 50 squared. When we do 50 squared, I'm going to write it over here, we get 3,600. 50 times 50, 2,500. If you have your calculator there, you would get 1.44 liters of water. So this involved a lot here. We had to find out how many seconds were in an hour. So that was that first part there. And then we had to take how many drops there were in an hour, which we found out was 36 drops, and multiply it by that 50 times the negative 2. Okay, so now let's look at number 10. If you want to try number 10 yourself, give it a pause. Okay. We already did the most of the work for this. So pause the video and see if you can figure out how to change it. If the faucet leaks water at a rate of 5 to the negative 5th liter. Okay, so they're changing that number. Okay, so if they change that number, we still know that there's 3,600 drops in an hour. but now we're multiplying it by 5 to the negative fifth. So we're doing the same thing here, except the number is changing a little bit. Okay. So we're going to have 3,600 times my placeholder 1, 5 to the fifth power. That's going to give me 3,600 times 1 over 5 to the fifth power gives me 3,125. So that gives me 3,600 over 3,125. When I do that in my calculator, I would get 1.152 liters of water. Guys, if you're really confused with the word problems, that's okay. I really want you to focus on what we learned here. That when you have an exponent of 0, it's a 1. It's always a 1. When we have a negative exponent, we have to flip that over that division bar and make it a positive. It's the same base, but the exponent becomes positive. So this is going to take some practice. I know you can do it. What you want to do now, if you want to rewatch the lesson, that's okay. Remember, you guys live in a YouTube age. So if you're really still confused, search out some YouTube videos. Okay, negative exponents, exponents of 0. So when you feel comfortable, look at that Google form, 10.4 video assessment. There's those 5 questions you have to do. And then there will be an IXL posted to go along with this lesson. You guys are doing a great job. It is really hard to learn math when you don't have your teacher in front of you. I'm really, really proud of you guys. I know you're really persevering and this is tough. All right. So we will see you soon. Please let me know if you have any questions or your teacher. Use the office hours. If you need me to meet you on a Google Hangout to explain some stuff, I don't mind that at all. Please just email me. Let me know how you're doing. And stay safe. Stay home. Be good. Make good choices. See you soon, friends.